Okay, thank you. Hi, everyone, and thank you for having me. Welcome to this month's community meetup. This presentation is called My Blog is Running on Istio. I'm Krisztian Fekete, working as a DevOps SRE engineer at LastPass, and I really like cloud native infrastructures, particularly the observability aspect of cloud native infrastructures. So starting from this and starting from my experience at LastPass, where we are using Istio in production, I decided to self-host and run a blog also on Istio to have a self-hosted playground to play around with technology. And I decided to put together this presentation to demystify the complexity of Istio by showcasing this simple use case. So first, what's Istio? Istio and service meshes in general provide a unified way to handle traffic management, service-to-service communication, observability, and security. Istio has a control plane and it's running sidecar proxies. These are envoy proxies next to your workloads. These sidecars are operating at layer 7, and with the help of them, Istio can provide these advanced traffic management, observability, and security features. First question, how hard is Istio? That's a question asked frequently because, mostly because Istio and service meshes are still considered hard. But why is that? And that's mostly because Kubernetes was considered hard or is hard currently, but actually how hard is Kubernetes? And the thing is, Kubernetes is becoming easier and easier every day. There are managed platforms on almost all of the cloud providers. You can spin up local clusters to develop and debug Kubernetes clusters locally on your laptop. And most of these are happening because it's becoming the de facto standard for cloud computing for tech companies at any size, not just at big tech companies, but starting from startups and regular companies as well. And how it became a standard? Because Kubernetes provides an extensive set of useful features that otherwise only could be covered by dozens of other applications, all stitched together with a glue, and that glue is specific to each and every company that's trying to solve these questions. Maintaining platforms and this glue is not easy. It's hard. So using a standard and using the abstractions of this standard is easier and more maintainable way to go. So let's go back to the original question, how hard is Istio? Well, that's good news because Istio is also becoming easier and easier as we are going on. Istio developers and maintainers are focusing on making it as simple as possible by improving on its operational cost, they do tasks, and they are lowering the operational and resource cost as well. The architecture is becoming simpler. You can adopt it gradually, and you can adopt and roll out the extensive feature set that Istio has feature by feature, which is a great way to get started with a service mesh and with Istio. On this slide, you can see the architecture of Istio as of the end of 2019, I think. Up until 1.4, the control plane at the bottom was basically a bunch of microservices, and operating them was troublesome. But flash forward to Istio 1.15, 1.5, sorry, and from this point, Istio is embracing a monolithic approach. Basically, it's simplifying the control plane by having a single service. It's called IstioD, and all of the other features that we could see at the previous slide are in this single service, which is basically all of our control plane. Other than this shift in terms of architecture, there are other under the hood improvements as well. You can choose between different installation methods. You can install the Istio services with Helm. You can use in-place or canary upgrades. You can use Istio operator. You can use a CLI tool to debug your mesh and apply manifests. You can choose between the multiple upgrade strategies depending on your needs and requirements. And with each upgrade going forward, these upgrades were more and more streamlined. I started with Istio at 1.5 at LastPass, and the first few minor version upgrades were not that simple to pull off in production. We had matching environment, and we have a dev cluster where we could try out the functionality, but there were use cases and edge cases where we were hit by that affected us. But fortunately, the community and the maintainers were always there to guide us through that phase. And compared to this, the last few upgrades were quite uneventful. And I think uneventful is a good thing when you are working in ops. Another great thing about Istio is that you can adopt it gradually. Istio is quite powerful, as I mentioned, and when you first glance at the docs and see the extended feature set and all the config options, it's very easy to get overwhelmed by the sheer amount of options, knobs, and all of it, and by the docs itself as well. However, if you can afford to look into the certain use cases that you are having problem with and you want to streamline, and you had the time to solve these one by one, adopting Istio gradually, then I would say this is the optimal way of adopting any new complex technology if it's possible. So let's get started with adopting Istio gradually. First, what you would need is the control plane, Istio-D. This component is the soul of Istio. It provides service discovery, configuration, certificate management, and that's basically the control plane of your workloads. As I mentioned, this can be deployed in multiple ways. There's Istio operator, you can use Helm charts, you can use the Istio CTL command line tool. Any of them is good, and you are safe to start with the default configs and profiles. Yes, there are Istio profiles. When you download a certain version of an Istio release, you will have default profiles readily available. So you can, for example, deploy a demo profile or a default profile of Istio locally in your cluster, and you can start to play around with it. You can have a look at the features, the config options, and you can go from this point. Yes, so there are a few ways to get started with the actual first implementation of deployment of Istio. Then there you will need an ingress gateway to expose your cluster. Ingress gateway is basically an ingress controller. It's a load balancer. It's operating at the edge of your service mesh. It receives incoming HTTP and TCP connections. And yes, that's basically an ingress resource in the Kubernetes worlds. There are other gateway and ingress resources. It's an optional tool. You are not, it's not mandatory to use this as your ingress, but just like with Kubernetes, one of the most powerful thing with Istio is that it's a single tool that can solve many of your problems, and as it's only a single tool, you can simplify your batch management and operation by having this single piece of software solving many of your problems. Next to the gateway, there's virtual service, which is an Istio specific CRD. It's an API, but you can communicate with it with YAML files, and it's implemented as a CRD. Basically, the difference between other Kubernetes ingress resources is that the gateway itself does not include any traffic routing configurations and capabilities. Virtual service is there to define these rules which want to apply when certain hosts are addressed. So in case of a simple use case and service, let's take a look at these services. On this slide, you can see Kubernetes manifest. It's a gateway. It's actually an ingress gateway. It's actually a simplified version of the gateway that I'm using for my blog. You can see that at the end, there's the usual metadata namespace for this resource. And this gateway itself can be deployed with the aforementioned options like Helm charts or Istio operator, Istio or Istio operator. This contains a simple configuration for port 80 and for 43. But other than this, I'm using a simple TLS instead of a mutual TLS, which can be also turned on when there's a clear need for that. But I'm just using a simple TLS for this ingress purpose, and I'm referencing a name of a certificate. And beside this, I have a redirect for port 80 to 443. And basically, that's all that you need to expose your entry point in the service mesh. Then there's a virtual service. You can define there's the usual metadata section. You can name it. You can specify a namespace. You can attach labels and annotations. Then there's the host, which is the destination URL. You have to reference a gateway to apply the routing itself. You can see that it's called plug, and if we go back to the previous slide, this gateway is called plug. So that will be the one that this virtual service will use. And the bottom section, the HTTP root destination host, is basically an HTTP. And these can either redirect or forward the traffic. By default, it forwards, and that's the way I'm using it. The forwarding target can be a service. For example, in a simple example, it can be a single service. But if you are experimenting with advanced features, you can specify a subset of other services as well. For example, to implement A/B testing, canary releases, or traffic splitting. So, what can this simple setup get you? There's an ingress controller, which is again optional, but one of the benefits of using Istio is that you can get away using only Istio instead of using dozens of separate services with all of their lifecycle management. Then you can have traffic management capabilities. Istio can help you start with fault injection, traffic shifting, circuit breaking, and more. These are optional. You can try these out one by one and adopt the one that you need. The great benefit here is that Istio and the invoice sidecars are helping you to solve all these without instrumenting your application with these logics, and your applications can focus on the business problems that you are actually trying to solve. Then Istio can help with observability. You will get service-to-service metrics. So basically, out of box, you will have RAD capabilities. RAD is, it stands for rate, errors, and duration. Basically, with Istio, you will have the golden signals readily available for your services without adding a single line of code to the specific services. Then Istio can, actually there's a typo on the slide because the second bullet point under observability should be workload level traces, because Istio can automatically add traces, trace spans for workload to workload communication within the mesh. It's a great foundation to get started with tracing. However, in order to these spans to be stitched together, to get a complete view of the traffic flow, the application itself needs a little bit of instrumentation. The application code should propagate the trace context between the incoming and the outgoing requests, so you can improve on this, but basically the service-to-service spans are covered with the Istio and the Envoy sidecars running next to the workloads. And as I mentioned, this simple setup is a great playground to build upon. You can experiment with all these features and proceed in your own pace. This is a screenshot of my blog. It's a very simple blog. Actually, it's a simple Hugo engine. It's rendering a static site. I'm hosting on a VPS provider. I have automation around to handle the provisioning of the VMs that this blog is running on. I'm using a simplified Kubernetes K3D to provide a base platform for Istio. Some Terraform module to spin this up in case I want to test aggregates or perform performance tests or try out new features without affecting my production website. And for the actual deployments, I'm using Hemfile, which is a great way to handle the dependency chain between the multiple Helm charts that are available for Istio. And on this slide, you can see the initial version of my blog's application dashboard. The great thing that behind the scene, there's only Istio and the Prometheus ecosystem behind this dashboard. There were not a single line of code added to the Hugo engine at the application level. What you can see here is all the default workload level metrics and for the request rate, error rate, latency, duration. And at the right side, you can see some logs. Those are the logs of the Envoy access logs that are stitched to this Grafana dashboard with Grafana Loki. But yes, that's basically about it. Prometheus, Grafana, and Loki is doing all the magic behind the metrics and logs that are available without any fine-tuning and adding these by hand. And if you want, you can extend all these. You can create more advanced dashboards. I have these running behind my blog, but again, there isn't a single line of edit code to the application itself. It's all the same default logs and metrics and traces that are available with Istio. On the right, you can see the traces itself that's added with Grafana Tempo, but there's no instrumentation at the application side. So that's another future improvement idea that I could add. but at this state, the idea is to leverage the default capabilities of Istio. So yes, that was about it. It's a bit overkill. Running a blog doesn't even require dedicated servers anymore. You can use Lambda functions and go serverless, but I wanted to have a self-hosted playground to experiment with the extensive set of features that Istio and Envoy can provide. And this fire, I really like the capabilities and the freedom that this self-hosted platform can provide me. If you want to move into the advanced topics, you can implement them at your own place, as I mentioned. You can add security headers with Istio's Envoy filters. You can experiment with A/B testing. You can shift a certain percentage of your traffic to a new modified version of your service. You can get started with chaos engineering by fault injection. You can implement rate limiting around Istio, around the Istio Ingress Gateway or the Envoy proxies. You can use locality-based load balancing for external services. So let's say you are relying on a third-party service or other regions, and if those regions or services are having an outage, you can shift your traffic automatically to the healthy port source services. So yes, the list is nearly endless, and it's really a great foundation to build upon. And that was my short introduction to this very simple use case of Istio. Thank you for joining me.